Hi, this is David Buckley, Black Rock Castle Observatory, and today we are going to learn how to make an inexpensive and effective way to demonstrate why the phases of the moon happen, and also, more importantly, where they are in the sky at various times. Now, there's a lot of misconceptions about why the phases of the moon happen. For such a basic astronomical phenomenon, many people don't understand it. A lot of children think that clouds cause phases of the moon, which of course doesn't make any sense because clouds are only a few miles over our head. The moon is almost 250,000 miles away. A much more common misconception that even adults have is that the phases of the moon are caused by the Earth's shadow falling on the moon. Okay, that is something that does happen, but it happens very rarely, and it's called a lunar eclipse. The Earth's shadow doesn't go following the moon around in its orbit around the Earth. Okay, so the phases of the moon are a natural reaction or natural occurrence because just like the Earth has a side that's in daylight and a side that's not in daylight, that's what we call our nighttime, the moon, when it's illuminated by the sun, has a daytime side and a night side. Because the moon travels around the Earth, when it's closer to the sun than we are, we see more of the nighttime side. And so the phases of the moon we see then are either crescent or new. Okay? When the moon is farther from the sun than we are, and it's sort of behind us relative to the sun, we see more of the daylight side and less of the nighttime side. So that's when we see what we call a gibbous phase, or nearly full. And sometimes when it's directly behind us, a full phase. A way that a lot of people try to use to explain phases of the moon is with a moon phase diagram. You have the Earth in the center, the sun shining from one side, the dark sides facing away from the sun, of course, and the moon's orbit with several different stops along its orbit, delineating where the moon is at various phases. The problem is a lot of people have trouble imagining what it looks like from the center of that diagram, looking out toward the moon. One way you can get around this is by making a three-dimensional version of this diagram and put yourself on the inside. I'll show you that in just a minute. It's a very simple thing to make. If you can't find a styrofoam ring that's at least 50 centimeters across, the next best thing is about a 2-meter length of pipe insulation. So you can get this at any plumbing store probably. And make sure you get the insulation that is not split, because you want it to be an entire cylinder. The other thing you need is some gaffer's tape, which you can also probably find at your local plumbing store. And the same color would be useful so that you can't tell where the seam is quite as easily. Now what you want to do is you want to make this into a ring. One thing you probably should do is take an old marker, one hopefully that can't be used anymore, and use that to help connect the two ends of the pipe insulation. This will prevent it from kinking after a couple of days, even though you might get a part that's a little bit on the linear side. Then you take the seam and you tape it around with the gaffer's tape. Okay. Then you have to decide exactly where to put the direction that the sun is shining from. Okay. What you want to make sure is that the seam is not a place where one of the moon models is going to be. You're going to want some small pieces of styrofoam, polystyrene balls, to represent the moon, and you're going to want to place them at various places. 8 of them are perfect. Various places along the pipe insulation. Okay. Now, it's a 2-meter long piece of insulation. You're going to want 8 equal distances. So that would mean approximately every 25 centimeters along the insulation you want to put a paper clip. Okay, the paper clip is what you're going to use to hold the little styrofoam moons. Now, for when you decide where your sun is going to go, and I used a larger styrofoam ball with it on a barbecue skewer, you put the sun, say, here, and that is where you're going to put new moon. So for example, a new moon, you're going to put your paper clip so that it is, the width of the paper clip is perpendicular to your barbecue skewer. Or in other words, the flat part of the paper clip is facing the sun. That's going to be true of all the paper clips around the pipe insulation. You want to make sure that the paper clips are facing flat on to the direction of where the sunlight should be coming from. Okay? Now, another part that's a little tricky is attaching the paper clips to the pipe insulation. Okay, you're going to want to open up the bottom of the paper clip and thread it like threading a needle through a piece of cloth, like so, and then bending it shut like that. And it does a pretty nice job of holding itself nice and steady here on the pipe insulation. Then you're going to want to take a sharp knife and make a little slit in your styrofoam ball, just big enough so that it fits snugly on the paper clip. And that is how you attach the moon to its orbit. Okay. The next thing you want to do, once you have all 8 of your moon simulated moon positions on the pipe insulation, is to color the side facing away from the sun black so that you have a daytime side and a nighttime side. And so you can see we have 8 phases of the moon. Now, of course, the moon takes almost 30 days to go all the way around. So every successive day, it moves a small fraction of this along its orbit. So it's roughly a week, roughly 7.5 days between the quarter phases, from new moon, first quarter, full, third quarter, back to new moon. Okay. The direction of the sun is where you have new moon. The opposite side would be full moon. As you go around anti-clockwise, you have first quarter 90 degrees away from new moon, and then third quarter 90 degrees away from full moon. Okay. Now, of course, what would happen is, and this is not to scale, the Earth would be in the middle here, and it would be rotating around once every day. The neat part about this is you can turn your head into the Earth. Okay? And when you're facing toward the sun, that would be noon. So you can actually mark your simulator noon, and then 6 hours later, you would be facing 90 degrees to the sun. The sun would be setting here in your west, and that would be first quarter. At sunset, you would see high overhead. And then 6 hours after that, at midnight, you would see the full moon. And then 6 hours after that, as the sun is rising, shining on your left cheek, that would be sunrise. And if the moon is facing you at that point, that would be when it's third quarter. Okay? So this gives a very good idea of where the moon is in the sky at various times, as well as the way the phases look. So again, the advantage of this is not only that you can see in 3 dimensions why the different phases happen, why when the moon is closer to the sun you see more of the darkened side, the nighttime side, than the day side, and why when it's on the other side you see more of the daylight side than the night side. But by turning yourself to various times of day and night, you can actually see which side of the sky the moon would be on. Is it on the western side or on the eastern side of your sky? Okay, and that is an easy way to figure out where the moon will be on a particular night. If you want to look up where the moon will be tonight in a calendar or on the internet, and it's a waxing crescent, well then you know that at sunset the moon will be over here on the western side of the sky, but not all that far of an angle from the sun. If it were a waxing gibbous moon, then the moon would be approximately a little more than 90 degrees away from the sun in the sky at sunset. and you would see it in the high in the eastern sky. In fact, the waxing gibbous moon is when the moon can most often be seen during the daytime, because even in the afternoon, about 3 o'clock, when the sun is still in the sky, the waxing gibbous moon is coming up in the east, and it's usually bright enough to shine through the blue sky. So I hope you can find a way to make this for yourself, and I hope you find it useful for yourself and your students in understanding the phases of the moon.